This is how to integrate using the reverse chain rule. So you're going to want to use this one when you can't use your power rules or rearrange it using any identities. And it's easy to do if you can spot what the original expression was that would differentiate to get your integral. But there's another way to test it if you're not sure with that. So I'm going to go with one of the two typical examples. So you either get the fraction or you get the product. So go first with the fraction. So we have the integral of x over x squared plus 4 dx. And first of all, to check if it's a reverse chain rule question, you get the higher power expression. So obviously there's the top expression and the bottom expression. The higher power one is at the bottom. So we're going to differentiate that. So derivative of this is 2x. Then if this 2x is a multiple of this x here, which it is, then you say yes, it is a chain rule. Brilliant. So now that we know it's a chain rule, we're going to actually do the reverse chain rule. So we've already derived, differentiated the bottom. So we're going to keep that and we're going to multiply our entire expression by the derivative, or the reciprocal of the derivative. So times by 1 over 2x. And now instead of dx, we're going to go d. So we're differentiating with respect to the thing we differentiated. So x squared plus 4. So instead, if we had x squared differentiates to 2x, if we have x squared plus 4, because we're differentiating with respect to x squared plus 4, that would differentiate to 2 lots of x squared plus 4. So we're just treating it like the x. That's how changing this part, that's how that works. Now we can cancel out. We have an x on the denominator and an x on the numerator, and that just leaves us with 1/2. Bring that out the front. 1/2 of 1 over x squared plus 4, and now that's d x squared plus 4. So imagine that's 1 over u, where u equals x squared plus 4 du, and that just turns to ln u. Well, in this case, u is x squared plus 4, so it's 1/2 ln x squared plus 4, then plus c. There you go. So you often get the fraction one, and there's also, as I said, the product one. So let's demonstrate. Let's say we have x plus 1, or the integral of x plus 1, x squared plus 2x plus 3 to the 4 dx. So first step, higher power expression. That's the x squared plus 2x plus 3. Derivative of that is 2x plus 2. Now that is equal to 2 lots of x plus 1. So it is a multiple of this thing. So it is a chain rule question, or reverse chain rule. Brilliant. Now with that derivative, we're going to multiply by the 1 over that derivative. So x plus 1, x squared plus 2x plus 3 to the 4 times by 1 over, and I'm going to use the factorized form, 2x plus 1, because then these cancel out nicely. And remember, it's with respect to the thing we differentiated. So x squared plus 2x plus 3. Brilliant. The 1/2 we can bring out the front. So 1/2 integral of x squared plus 2x plus 3 to the 4 d x squared plus 2x plus 3. And again, it's the same with our u's. So it's like we have 1/2 integral of u to the 4 du, where u is equal to x squared plus 2x plus 3. So that would become 1/2 increase the power 5 divided by new power 1/5. 1/5 u to the 5. However, u is equal to this, so it becomes 1/2, or 1/10 is 1/2 times a 5th. 1/10 x squared plus 2x plus 3 plus c. And now we're done. Brilliant. Again, if you spot the original expression, then that's easier, but this is the surefire way to do it every single time. So I hope that was helpful.